Thank you so much to the both of you for being here and for having this conversation. I'm really excited to talk about this. I think in the introduction, we basically heard the premise of this conversation, which is that over the past 3 years, there's been a lot of attention on the AI labs, the frontier labs, the software side of the industry. But hardware is such a critical part of this AI explosion. And right now, it seems like every day, quite literally, we're hearing there's not enough compute. There are not enough computing resources. And you both, Micron and AMD, are at the heart of that. First, I wanted to ask you just to pull back a little bit. In your careers, have you seen anything like this compute demand that we're seeing now?
Well, I'll go ahead and start. I've been 4 decades, Lauren, in the industry, and that's through the whole PC revolution, the internet taking off, mobile devices, but actually nothing compares to what we're seeing now, because AI is so compute hungry, and now we all have access to it, and we're all just starting to see what it can do. So the short answer to your question is simply no. This is much larger and much broader than any of the transitions.
Yeah, I mean, same thing here. I've been in the industry for over 3 decades, and the level of demand we are seeing for memory and storage is unprecedented. AI is extremely memory intensive, and consequently, the gap that we are seeing between the demand that the customers are placing on us and our ability to supply, not just as Micron, but as an industry, that's the largest gap in the history of the industry. So it's a very, very interesting time from that angle.
And Mark, we were just talking a little bit earlier, and I made the observation, one of your partners is Meta, and I said, isn't it interesting how Meta is now working with NVIDIA for CPUs and turning to AMD for your MI Instinct line, your GPUs, and in another universe of chips, it would have been the opposite. And you said, Lauren, everyone just basically wants everything right now. Talk a little bit more about that.
Sure. It is this explosion of compute. You see this with the hyperscalers, and Meta is a great example of that. So we and Meta announced a 6 gigawatt deal to supply computing. It's actually is CPUs and GPUs, and of course they go out to the industry and have other solutions as well. And it just reiterates the point that there's just this insatiable demand for more computing. So no one's using just one solution. And AI is not one type of workload. It's a diverse set of workloads. So it makes sense.
Sumit, being in memory, the memory market is getting a ton of attention these days, and it's because of a well-recognized memory shortage. I'm going to assume that a lot of folks in the audience have been following this and sort of know what's going on, but in very basic terms, can you explain why there is a memory shortage? And then I want to ask you more about what Micron is doing to sort of get past that bottleneck.
Sure. So late last year, in the 3rd quarter of calendar 25, we saw a very massive step up in demand across all of our data center customers. Meanwhile, the demand from other segments of the industry were steadily increasing, again due to higher memory content driven by AI in part. But the step function increase from data center customers was pervasive and the biggest we have ever seen. And the demand has continued to strengthen from that point. And it is back to what Mark said about the insatiable appetite to deploy compute solutions, because we are still very early in this journey to deploy AI at scale. Most corporations around the world don't have solutions deployed in their companies that leverage AI at scale yet. They're all starting to experiment, and already the infrastructure is completely fully utilized and then some. And part of the challenge is that the supply requires greenfield fab capacity, which takes years to bring online. And that's the gap which is causing us to, as we sit here today, not clearly be able to see the timeline on which the supply will intersect with demand. It's not easy to see when that will happen, because as we look out in time when supply comes online, the demand signals continue to escalate.
And the memory industry has gone through these cycles before as well, and then typically what would happen is at some point the new capacity is built, and then there's not as much demand, and then prices hit the floor, right? And so, but you're both describing a dynamic now in which you've never seen this much demand before. So when you think about sort of projecting out, like what are your kind of gauges or your estimates for how much memory you're going to need in the next 2 to 3 years?
So we are making fairly substantial investments to bring on more supply, to ease some of this burden that our customers have of not being able to deploy as much infrastructure as they want, or as many devices as they want to sell. And so this year, we announced that we will be spending over $25 billion in CapEx from $20 billion was the earlier estimate just 3 months ago. And we also mentioned that next year, just the construction CapEx increase alone will be over $10 billion year over year. So these are massive numbers. And so what we are doing is also telling our customers to co-commit in this journey with us, which is to do multi-year deals, and we have announced our first 5-year strategic customer agreement. And we have others that we are working on across a broad range of customers, so that our customers also take ownership and responsibility for the demand signal that goes out 5 years, for example, which is a very big change from how things have been done historically.
Oh, interesting. Okay.
Can I add a little color on that cyclical memory demand? The reason I am so confident this is a long cycle of high demand is that it's really the change in how people are deploying AI. I mentioned it earlier, these agentic flows. So if you think about, Lauren, how people were running computing, they were using GPUs primarily for the AI. It was largely training.
For training, yep.
Right. And now it's a steep rise of inferencing. But it's not just inferencing, it's running agentic flows. And agentic flows is any of your workflows. Think about what you're doing at work or what you might do if you're in finance. You're closing the books every quarter. You're optimizing a manufacturing line. Whatever you're doing, you are running a lot of workload on CPUs. And now that's intensified. And so it's not just CPUs, but now there's a huge increase, not just GPUs, huge increase in CPU demand. And there's different memory types, but that causes, for Sumit and the other memory suppliers, just a compounding effect. And that's, again, why I'm so confident this is a long cycle of hyper demand.
How good does it feel that CPUs are sexy again, Mark?
It does feel good.
It must.
We've been hard many years at having the most efficient CPU out there, and we're proud to have that complement. And again, I think we'll get into it, but it really takes an industry. So that's why it's great you have Sumit and I together, because we all actually have to work together to build the compute systems.
And explain that. Explain some of the partnerships that Micron and AMD, for example, have forged in order to meet this demand.
You want to start?
Yeah, I can start. So the memory ecosystem has become a lot more complex. We have HBM, we have DDR5, we have LPDDR5, which is the low-power version of the DRAM. And of course, we have NAND storage as well. And we are working with AMD across all of these through actually defining the spec in JEDEC in a joint fashion like we are doing with DDR6, like doing joint development on critical aspects of the HBM design, because the HBM has to be so closely and intimately tied to the GPU. So it has to be really a very extreme co-design type of an approach. We share simulation models, verification models, thermal simulations, and even EDA tools that can allow us to go back and forth between companies. And then on reducing the power consumption in data center, how do we accomplish that? And we have pioneered the use of low-power DRAM in the industry. So Micron was the first company to bring out LPDDR for the data center in 2025, and now the first company to do so with a 256 gigabyte capacity point, which AMD is leveraging on its Verano CPU platform. So we are very excited to partner with AMD on that. And we're also doing the Gen 6 SSD on the Helios platform with AMD, also the world's first Gen 6 SSD for AI infrastructure.
Yeah, I'll build on that. I'm going to start with, Sumit mentioned open standards, how we partner. I mean, memory industry is a great example of a commitment to open standards. And so we have worked very, very closely, and I could rattle off several efforts where Micron and AMD worked and came up with ideas, but partnered with the rest of the industry on the standards that were aligned. And this is so important to us at AMD. We're committed to open standards across every aspect of the entire compute complex we build up. And it gives customers choice. It ensures, frankly, that customers have a better management of supply risk. And yet, every company can still differentiate on top of those standards, and we protect each other's IP in that mode. So it's very, very healthy co-design, and these open standards across not only hardware, but in our case, all the way through the AI enablement stack, I think are hugely important for the industry.
When you think about innovations that you're both exploring in order to address these bottlenecks, I wonder, and the answer is probably both, but is it more critical in this moment to focus on innovations at the component level? Maybe it's exploring faster interconnects or photonics or diamond cooling or whatever it might be. Or should the innovation concentration really be at the manufacturing level right now because scale? Like, how do you think about approaching those?
Well, I'll start. The power demands are so high when you look at the amount of compute that's going on. I mean, that's why they're gigawatt scale of clusters that are being built up to do all the AI processing, that it really demands a co-optimization across the full solution. And so what we try and do is we really break apart the problem, because you have compute and you have to feed that compute, and that's the movement of bits. And so you really have to optimize in parallel each of the components, not just stand alone, but how the components work with one another, and how, in fact, how they're manufactured to ensure that they're manufactured with efficiency. So it's putting more of a stress on co-design than I've ever seen before. And again, we embrace that.
Yeah, I completely agree. I mean, the manufacturing aspect has its own separate vector, right? We have to scale, we have to find more supply sooner in order to help satisfy customer needs. But we also have to focus on some of the critical bottlenecks. Power is a big one. So one of the things that Micron has done is to focus on how can we differentiate in power. So our HBM3E, for example, has been 30% lower power consumption than the next best product. And our HBM4 steps down the power consumption from HBM3E by another 20%. The low power DRAM cuts the power consumption by 2/3 versus regular DDR. And there are lots of innovations in order to overcome some of the issues of deploying low power DDR in a data center, like focusing on reliability, availability, and serviceability. And we have pioneered a lot of that work. So finding a way to maximize compute in a data center, because power constraints are so real and so big, is a big focus for us.
What are the most exciting innovations both of you have seen or explored around the problems that you're addressing with power?
Well, we've had to rethink how computer chip design is done. So we pioneered at AMD using chiplets rather than building one chip to have a monolithic solution, how to partition to really optimize what gets done on each technology node. Where do you need the most cutting-edge technology mode, likely the CPU or in all cases, the CPU and the GPU chiplet. But then taking our circuitry that talks to I/O or that interfaces with memory, those can be done on a n-1, a previous node, or even an n-2 node. And by putting lateral silicon to silicon connectivity and then stacking, which we do with our logic chips and that Sumit does with his memory chips, you create a proximity. So the information flow is going from chiplet to chiplet on silicon. It's not leaving the silicon, and that creates an excellent energy efficiency.
What's the next version of that, do you think?
Well, we're going more three-dimensionally. We already have three-dimension. Our MI 355, our whole MI series is using 3D stacking today. But you're seeing, again, the movement of bits being optimized. We're constantly working between Micron and AMD to optimize the movement of bits. Photonics is now coming in as a more efficient way to scale up each of our sleds as we build up these massive racks. There's quite a bit of innovation coming, all trying to minimize the energy expended as we talk between compute, memory, and devices connected over I/O.
Sumit?
I think Mark mentioned a few very important vectors. We are focused on ensuring that subsequent generations of HBM bring down the amount of power used by a unit of bandwidth in a very meaningful way. Similarly, when we came out with the industry's first 256 gigabyte LPDDR for the data center, we halved the power per gigabyte, which means the 256 gigabyte module was using the same power as a 128 gigabyte module just last year. So these are like not 10, 20% type of differences. These are like step function changes in what we can do with a given envelope of power to maximize compute density inside a data center. And then other techniques include how to bring memory and compute closer together. We have been exploring things like compute near memory and even some level of processing in memory. So these are all types of future vectors. And of course, logic will deploy more optoelectronics in the future. That's going to be another vector to ensure scalability with power efficiency in mind.
Just to add on our co-design discussion earlier, Sumit just mentioned that low-power DDR going into the data center. Those low-power memories, that's what's in your phone. So it's been mass deployed in mobile devices, and now it's in the data center. So that took tremendous co-innovation. We just put out a blog yesterday of work we did with Micron and the memory industry to add this low-power DDR in our server. And what that meant is you had to innovate on how it can be maintained in a server, how it's a different form factor was needed. It runs at a lower voltage. It has to have the reliability that you expect in a data center, much higher than what you need in that low-power memory that's in your phone. So it's just a constant flow of innovation to bring more efficiency to compute.
I asked your CEO, Lisa Su, a version of this question last year at our Wired conference, but with all of this incredible amount of capital going into building out infrastructure, and I think particularly with some of the AI frontier labs, there's some concern that we're not quite sure how much revenue they're able to generate just yet from their AI services. They share some data, but they're privately held, and et cetera. So how likely is it, do you think, that some of this investment in AI infrastructure that's happening right now could essentially backfire, and that there would be a contraction or perhaps a pause or a slowdown in the kind of build-outs that are happening right now?
Well, we're running on AI time right now, and in AI time, it's hard to even project past 2 to 3 years because there's such a high rate of innovation. But when you look at that window, we feel it's a very contained risk. When you look at the investments we've made in data centers, because we now co-invest, just as Sumit talked about a co-invest model, we're co-investing in building up data centers. And that means we're leaning in, and we have to get what's called off-takers, people that will sign up to consume those CPUs and GPUs. And the demand's extremely high. And with the trends that we talked about earlier, again, in that window of visibility we have, I don't see that changing. That's not to say that if someone doesn't manage a data center well, it's not run well and planned well, you may see spot issues. But I think at a macro level, Lauren, it's a very robust environment, clearly in that window of visibility.
Yeah,
Here, another version of that question for you, Sumit.
Sure.
Are we in a bubble?
Well, AI is truly a transformational technology, and its impact is going to go across the entire economy in terms of transforming entire industries. And it's not just about productivity, it's also about spurring innovation, coming up with new ideas and new capabilities that AI will enable us with that was not possible earlier. There is no doubt there is a lot of investment going into it, but our customers have very deep conviction about the value and the ROI that these investments will drive. And they are in a multi-year build-out phase, which they have conviction about in terms of the trajectory and the extent of investments that they are making. And in these strategic customer agreements that we are discussing with our customers, they are going way beyond any historical effort to put specific commitments in there to ensure that our CapEx investments also have those backstops and safeguards.
We have about a minute and a half left, and I wanted to do a quick rapid fire round with the both of you. 3 questions. The first one is, since we're at HumanX, which element of your job is not likely to be replaced by AI anytime soon? Super fast.
Well, for what we do, it's that strategic element of trying to put the dots, connect the dots together that you would not naturally think were connected, that you've just got to have experience and, frankly, a gut feel.
So strategy is
strategy.
Yours. What's yours?
I think jobs that require significant human judgment versus ones where there is a lot of scope for automation, repetitive type of actions. I think that human judgment aspect is still some time.
Human judgment. Okay. Second question. What's the last thing that you vibe coded? That you vibe coded?
Vibe coded. I am just coming up. I actually, my kids are very big into AI, so they're currently getting me up on how to actually vibe code. So it's coming.
I have built an app to figure out what are the best stocks to invest in. So I'm trying to see how that works.
Are the best one. What was that? I didn't actually hear it.
An app to figure out what are the best stocks to invest in.
Oh,
so.
Amazing. Okay, my last question for you. You're both launching a new product right now. You're launching a new chip. You're launching a new type of memory. What do you name it?
Well, we're rolling out our MI400 family. The MI455 is the Helios rack. We've had to now design, we used to be a chip company, we had to design a full rack level. So it's the compute, the memory, the networking, optimized across as a whole, including working with the software partners. We're super excited about it, and it's going to be a real catalyst. And again, that's what's behind those multi-gigawatt deals we
You get to invent a whole new name, Mark.
Yes.
This is your chip.
We had to invent a whole new name for what we're doing.
What would you call a new type
that
of memory?
Our product names are so geeky that I'm looking forward to using AI to come up with better names for our products.
So you'd ask Claude. Okay, great. Sumit, Mark, thank you so much for this delightfully nerdy conversation. Thanks all.
Thank you, Lauren. Thank you all.